In this video, let's explore a task that we've had to do many times before, and we're going to again address this by using a function. And one of the things we've had in common across many different databases is if we are processing orders and we have some table that collects the orders and another table that has the inventory items that are being ordered. We are going to have one table that's going to have the unit price, and then we're going to have something that is like an order line table or a line items table that's saying, well, how many of what item did you buy? And then what we need to do, of course, is if we're going to create a invoice for the customer, is we're going to have a line item total, and ultimately we're going to have a grand total for the whole order. But if I order 12 pencils and the pencils are 10 cents each, I need to multiply 12 times 10 cents and come up with the total for that line item of pencils of $1.20. And then if you bought pens and sticky notes and other things on that order, those would be other line items with their own totals, and we would total up the line item totals to get the grand total. Okay, so right now we're just taking a little piece of that. We're going to find the line item total, and we're going to do this in My Guitar Shop. And we're going to call this function function item total. And we'll start building our script with the usual conventions. Let's have a start so that if the object already exists, let's clean it up from the last time we built it. If we're doing a new version or we were testing and whatever, this was going to clean it up. If it's already there, we'll delete it. And now we're ready to, after this go is executed, that will have been done before the next batch is started, and we'll be able to start creating the function. And let's look at how this function is to work. So we can even start coding before we have, or setting up the header for the function before we really know everything about how the details of the function work. And a lot of times your projects will be scoped that way. And so we're going to create a function. It's going to be function item total. It takes as a parameter item ID as int, or at item ID is going to be the name of the variable. And it is going to return a data type of money in the thing that it returns. Okay, and then we're ready to start, and we start by declaring the at item total variable as a money data type. Okay, so now we've got the declaration set up, we're ready to start building our logic. Well, what does the logic have to do? So again, write a script that creates and calls a function named function item total that calculates the total amount of an item in the order items table, and that is given the formula discount price multiplied by quantity. Okay, so that's ultimately what we're going to calculate. And once we've calculated that, we're going to return it. For what are we going to return that? One would presume we're going to use the primary key ID of each record to return that one quantity. Okay, so let's think about in general what that query is going to look like. So we're going to have, no surprise here, we're going to select something from a table or tables, and it's going to have some filter criteria. So what are we selecting? Basically, we're going to be selecting the, let's see, the quantity times the discounted item price. Well, where do we get the discounted item price? Aha, previously we had a function that we had created called function discount price, and we would pass it the item ID, and then we would multiply that by the quantity, which is how many of them we're ordering, and we're doing that on just a single table, order items, and we want to filter that for where item ID equals whatever the parameter is that's passed. Let's put that to sleep for now, and let's just test this query And again, the function discount price must already exist, and it does. We can refresh things and come out here and double check, okay, it exists, and we can fully qualify that. And let's see if that much is working. Yeah, okay. And if you wanted to sanity check that by first selecting out the other fields so you can see that this calculation is correct, I'll leave that as an exercise for you, but I'm satisfied that it is. I've already tested that function, and so that's pretty good. And then all I will need to do is to add in my filter criteria, and that is going to filter it down. I want to get one value returned only for the row in question that's being processed, because that's how I'm going to use this function. So that's going to look like, let's go ahead and build it now. We'll convert this to the actual function body. So where item ID is equal to, and the criteria is going to be provided in @item ID. Okay, and then we're going to take this, and this expression is going to be stored, the result of this expression, I should say, is going to be stored in @item total. Okay, and I've got one more job to do. Do you remember what it is? I need to then return the value from this function. Okay, so what am I going to return? I'm going to return @item total. That was the whole point. And then remember that I'm still working within a begin block, and every begin block should have a balancing end block. So now we're going to put our end block in there. And this little habit, the computer does not care, but the habit of indenting helps you to see where you have nested the beginning and ending blocks in your code. And so that is very useful as you're building, to make sure that you have matching and completed structures. For every start, there's an end. For every begin block, there's an end. Or every start of a transaction, there's an end transaction. This is a good habit. It's a standard worldwide. And so you should probably get in the habit of using it, just because it is so practical and can keep you from making mistakes, because your code becomes hard to read if it's not structured and indented this way. Okay, so again, not a requirement by the computer, but very much a requirement probably by your supervisor and your shop standards for the employer for whom you are working, and it's just good practice. Okay, so we reached the end, and remember, this is intended to be building a script. So let's execute that part of the batch, and then we would go ahead and start using or testing that function. So let's go ahead and let's just run everything, and we should see success come back in creating a new function. And the function is going to be function item total. So if I look at the functions I have now, I have DBO function discount price. When this runs, I should add to that function item total. So let's see if that happens. So execute. It says, well, it completed successfully. How do I know? Let's refresh this. And now, indeed, I have a second scalar function that has been created, function item total, to go along with function discount price. And now what I need to do is test it. And once again, your documented solution should include all this code. I'm going to emphasize that this no longer plays a part in using or exercising that code, because the function has now been created. I'm just going to delete that. And we can even delete the commented instructions. And let's go ahead and just craft a query to exercise that. Okay, So here's a query, select item ID, item price, discount amount, and then here we go. We're getting the discount price. That's the function we'd created previously. And then we're calling function item total. This is really the one that we haven't tested yet. And we're going to alias that as item total. And again, there's nothing special or magical that needs these to be called out as a separate field. We could put them up here on the same line as long as the line doesn't get too cumbersome to read because it's so long. And again, this is what we're going to give special scrutiny to. Is that working correctly? So let's go ahead and run this. Tidy up this space if we like. Run that, and it is working. And let's see the item total. So if I had one, I should have the same as the discount price. But if I have two at roughly $840, so it ought to be $1,680 approximately. Yeah, it is. So that sanity checks nicely. Here's three at almost $500, should be around $1,500. Yeah, so that sanity checks, and I am satisfied that that function is now working. And you could start to see how, now these are pretty trivial calculations. You might elect to continue to do them right in your queries ad hoc, but some functions you are likely to do might get fairly sophisticated. And so rather than having to have those calculations right in line and making your code really cumbersome, we can build them into functions, and that means less things to type, means less chance of a typo, less code to write. You're gonna code a little more code every day, a little faster. So that makes you a more valuable employee and more productive. That's a good thing. And the other thing that's really nifty is some of these functions, which may be sophisticated, they may be driven by business rules. And if your business rules change over time, every query that uses that function, if you go in and change the definition of how that function operates, the other queries that call it still are calling that function by name, which means they auto-magically inherit all that creamy, golden, delicious goodness of the improvement that you made to the business rule. And you have one place to change all of your code for every part of the database that uses it, and every application, app, or web page that is dependent upon that downstream immediately gets that update and that new calculation. So we don't have to change it in the app and in the FAT client and in the web page application that uses it. So it's really efficient and good design, and means I have the code in one place to modify it rather than having to fix it in at least 3 different platforms and possibly more. So good stuff, and I hope you enjoy exploring, creating functions and using functions. And we will continue this lecture series with some new topics and elaborations.